Hi, everybody, and welcome to another episode of the Infrastructure as Code podcast. I'm Ohad Maislish, your host for today, and I'm very happy to introduce our amazing guest of today, Liz Rice. Hi, Liz.
Hello, thanks for having me.
It's definitely our honor and our pleasure. Tell us about yourself. It's a very impressive background, so please share about your background, please.
I am Chief Open Source Officer at Isovalent, which is the company that created Cilium networking solution that people probably may have come across if they're in the cloud native world. I have been involved in eBPF, which is a kernel technology that Cilium's built on. I wrote a book about that. And I've also been involved in the sort of cloud native security world for quite a while. There's an overlap between those two things. So I wrote a book about container security a few years ago as well. And I guess people, may have run into me if they've been to a KubeCon. I've been to pretty much every KubeCon for a long time. So yeah, very involved in the cloud native world.
Awesome. So let's talk about how cloud native changes the way you need to address security, you need to address how you handle networking. When you and I talked earlier, you've mentioned how dynamic things are today. Can you elaborate on that trend, please?
Yeah, absolutely. So, in the old days, you used to be able to identify an application by the IP address of the machine that it was running on. In the
Mhm.
cloud native world, we have, some number of machines and applications could be running anywhere across that cluster or across multiple clusters. They come and go, they scale up and down dynamically. And it means that IP addresses really aren't terribly meaningful anymore. So the things that we used to do around, network firewalling based on IP address and port tuples, it doesn't make sense in a cloud native world. So being able to use Cilium to understand Kubernetes identities and container identities and use that to sort of identify how to um, connect between different endpoints and also how to enforce network policies between endpoints based on the Kubernetes identities themselves, and through that, the actual applications itself, it's much more meaningful.
Yeah, definitely. So, I remember learning in college the layers model. You have an IP, then probably use TCP, then you use a protocol, let's say HTTP. But everything starts with the IP of the machine in which something is being run. Now, today it's not necessarily, as you mentioned, a machine. When everything runs within Kubernetes, or not everything, let's say most of your compute resources are now Docker containers within your Kubernetes cluster. So you have those pods that are very, as you mentioned, dynamic, auto scaling, going up and down, restarting. Each one has like a different address of a pod, and Kubernetes manages the networking within. So I am wondering how risky it is, for an organization which runs Kubernetes and wants to make sure that everything is secure and the traffic is going from one direction to the other direction, and that you have those limitations and rules to prevent some abuse or some attacks on your infrastructure. So, what does it mean, a rule that you drop a packet within
Yeah.
Kubernetes, within Cilium? Like, how is it done nowadays?
Yeah, so Cilium can use this eBPF technology, which allows us to make the kernel programmable. So we can program essentially the way the networking stack within the kernel behaves. And for example, we can have network policies that will look at the source or the destination Kubernetes identity information, maybe
Yep.
even layer 7 rules, not necessarily just the layer 3 4, but also being able to interpret the protocol and drop packets to enforce network policy. And the fact that we've got this kind of understanding of Kubernetes identities makes it easier to think about things like, should this service be able to talk to that service? Should this service be talking to the payment processing service? Should this other service be talking to an external, should
Yep.
it really be going to cryptocurrencyminingpool.com? Maybe not. So it becomes a bit more human to be able to articulate network policies in terms of this service should be able to talk to these other services, it should be able to talk to these external domain names, and anything else is out of policy, and those packets should be dropped. And
Yeah.
those policies work even though the pods backing those services are coming up and down dynamically.
Yep. Yeah. I remember, working. I had the honor of working on the firewall, leading firewall by Microsoft like 25 years ago. And when you think, what are the rules, what you allow and what you forbid? So the business challenges are always, you don't want somebody to hack, and maybe one risk is to use your infrastructure for crypto mining, as you mentioned. But there are tons of other risks like accessing your payment system and doing malicious things. But like 25 years ago, it was pretty standard kind of traffic, and now everything is way more dynamic within your Kubernetes cluster. And thanks to eBPF technology, you're able to examine the traffic and make decisions very efficiently when it comes to performance. Is that right to say?
That's exactly right. Yes. And the other thing that we've been able to do, and this really kind of came from customers originally from Isovalent's enterprise distribution, people saying, well, this is really great. We've got this, these sort of forensic logs of out of policy events. But if we see traffic that we didn't, that's out of policy that we think looks suspicious, it would be really great if we knew not just what pod that was originating from, but if we could find out some more information about what had triggered that. So we now have, and it's part of a Cilium sub-project called Tetragon, the ability to sort of not just trace, the fact that a network packet has, either been blocked or been received or sent, but also tracing back, okay, what's an application that created a network connection, and what was the process that was running, what container was it in, what node was it running on, which user started it, what was the process hierarchy, and then really having that kind of forensic information that if we do see something suspicious, you can trace it back to okay, what's the kind of root cause of this network traffic?
Yeah, that's exactly what I wanted to say. Having an efficient root cause analysis process is critical to really fix the issues, and not just to block something, because maybe blocking something is just the end result of a much bigger thing that you need to handle and remove from your data center, from your cloud account, from your Kubernetes cluster, something malicious that is running.
Yeah, I mean, if you do detect one malicious thing that's happening, you know that you've been compromised in some way, but you don't necessarily know what other things you haven't seen yet. So yeah, absolutely, you want to be able to figure out how that compromise has happened, or what that compromise is, and where is it, and how can we get rid of it.
Yeah, I think it's maybe if you go into a bank or a casino and then you manage somehow to go into the safe, but when you try to open the safe, you cannot break the safe, and then you leave. I think the security folks would not just be happy, yeah, the safe works. They would try to understand how the hell did that person went all the way from the entrance of the building all the way to the safe room. So you need to understand what happened from the moment it became a risk.
Yeah, absolutely true. Yeah,
So
defense in
just
depth
to
is a real thing,
so let's try to understand the different layers of the different components here. So let's just focus not on Isovalent for the next couple of minutes, on Cilium. What does, if I use Cilium, which is, by the way, correct me if I'm wrong, an open source CNCF graduated project. So congrats on becoming a graduated CNCF project.
Thank you. That is
So
correct. Yeah. Yeah.
so if I just use that and I don't use Isovalent, what
Mhm.
what value do I get from that?
Tons. I mean, almost everything that you need functionality wise, well, everything
Mhm.
that you need functionality wise is available in the open source Cilium project. I mean, there are some enterprise features, but we very much want it to be that if you can operate your Kubernetes cluster, you can do, even things like multi-cluster with the open source project. And really, the enterprise features are much more targeted at the kind of thing that you want if you want to pay money anyway. If you're the kind of consumer of technology who wants somebody on the end of the phone and wants to be able to influence the roadmap and wants to know, have like commitments to particular features and so on. So those are things that you don't get with open source. You don't get support, you don't get committed deadlines. But the functionality in the open source Cilium project, if you're looking for network policy, connectivity, multi-cluster, layer 7, observability, all those things exist in the open source project.
Got it. So there are no enterprise features in the product of Isovalent,
No.
unlike Cilium.
There are some enterprise features, but they're very much targeted at the kind of thing that you are only going to want if you are a very large enterprise or you are
Such as
very regulated business, that kind of thing.
such as what would I like as a heavy regulated customer in Isovalent?
So okay, a couple of examples of things that pop into my mind. One is high availability for egress
Mm,
gateway. So if you can
mm,
have an egress gateway, but if you want to be able to have a failover right now, that is an enterprise feature. Um,
got it.
or another example would be HTTP packet parsing, which we have in the open source project, but in open source, it's done in user space. And we have a eBPF implementation, which is faster in the
Mhm.
enterprise project. So, the capability exists. You might see performance improvements and latency improvements.
And if I am now a curious developer that wants to implement this thing in eBPF within the Cilium project, and I open a pull request, and is there, if I look at the vision, how Cilium would look like a couple of years from now, do you think some of those enterprise capabilities will eventually either by Isovalent and now Cisco, not sure if we've mentioned the acquisition by Cisco so far in this episode today. So do you expect Cilium going forward will accept community contributions that maybe overlap with what Isovalent
Yeah,
offers
yeah,
today?
absolutely. It's happened in the past, and I'm sure it'll happen in the future. Um, it's a CNTF project, so we,
Mhm.
play by the rules, and we might reject things because we don't agree with the implementation. But that it will become a discussion about how do we turn that
Yeah,
implementation into
an
something that does
RFP.
fit
Yeah.
the architecture. But so I'm not going to say that we accept every LPR that comes along, but we'd never reject something purely because of it doesn't fit with ISO. But things evolve. If the only
Mhm.
thing that's protecting your business is something that somebody else can contribute in a PR, you need that's not a sensible business to be in, and the kind of customers that we work with are valuing a lot more around the sort of partnership, the ability to influence what Isovalent is working on and what the roadmap is. There are enterprise features. There are some things that are better connected together in the
Mhm.
enterprise features.
Definitely.
But if you have a lot of the time as a customer, you can make a choice between putting your own resources into something or in paying for the enterprise version that has those things kind of glued together for you.
Definitely, definitely. And you've mentioned the fact that it's CNCF, and that's what that was going to be my next question, because CNCF doesn't just come with its name; it comes with a lot of great best practices and governance that basically ensures that the community is properly involved within those projects. Can you zoom in on that? Because Cilium started as an incubating project, correct me if I'm wrong, and then evolved into a graduated CNCF project. Can you share more, both from your experience in Cilium and also your wide experience working with the CNCF in general? Can you zoom in on
Yeah.
what does it mean to become a graduated CNCF project? Kubernetes is obviously a graduated CNCF project. I think Open Policy Agent and Istio and others are graduated projects. I hope I didn't say anything wrong. Can you explain to our audience what does it mean to become a graduated CNCF project such as Cilium?
Yeah, you're correct on all of those projects. I
Mhm.
believe they are all graduated. So I used to be on the technical oversight committee for the CNCF, so I've seen it from the perspective of how we kind of evaluated projects, and also I've seen it from the perspective of Cilium as a project maintainer, and going through the process that way. So really the things that the CNCF is saying when they're graduating a project is, this is, de-risked. This is ready for, and is already, adopted into production. So it's giving users confidence that, the project is well maintained, that it does play by the rules and has governance, sort of open governance, that allows for community members to contribute features, and that it's passing things like security criteria. So CNCF funds security audits for projects as they're going to graduation, which is great. And having things like a good security policy. Do you have a way of reporting vulnerabilities? How do you react to those vulnerabilities? Um, License checks. There's all kinds of things that the CNCF is evaluating. But I think really fundamentally it's about, is this a stable project that we believe has, a long future ahead of it? Nobody has the crystal ball, but given all the information we have, do we think this project is on a good footing to? Because if you're a consumer of that project, you're going to be investing, time and resources into using it and to, configuring it and setting everything up. So you want to know that that project is going to be good to rely on for, the future to come.
I think this is beautiful because I'm also familiar, and I'm sure you are, with the, let's call it, other types of compliances, such as a SOC 2 compliant. Okay, let's say
Mhm.
your software is SOC 2 compliant. That's one type of report that has its own set of rules and criterias. But I think what's very beautiful about the CNCF, how it's driven by the community and makes sure that this project is following the best practices, and dramatically, I think that's the key, dramatically reduces the risk of using this technology in production. And I think there are some crazy risks going around. Just a few weeks ago, about this unknown user that has worked for a few years to build its credibility and then
Yeah.
started injecting code, malicious code, into key parts of the Linux operating system. So, there are so many types of crazy risks. And I think what's beautiful about the CNCF, that it's adjusted to the modern life risks of code, and it's not based on some criteria such as SOC 2 that were created decades ago. So I
Mm.
think is for me the CNCF is pioneering the new type of compliance on how trusted software should look like. Would you agree with this type of
I do,
observation?
and I think it's a learning process. It's continually evolving. I mean, I
Definitely.
certainly have been frustrated with compliance guidelines before in the past, where the rules very much are known to not be password changing passwords is a really great example.
Hmm.
It is absolutely known that humans, if you ask a human to change their password every 90 days, they're going to start writing it down, or they're going to start following a pattern. It's a
Yep.
terrible thing to do from a security perspective. And yet for years, there were compliance requirements that just say, yeah, you've got to change passwords every 90 days. Well, the good thing about something like the CNCF is it's not like changes necessarily always happen quite as quickly as we like, but you can make PRs and propose changes and get things moving and adapting really pretty quickly and efficiently. And as a community, there's a lot of people with this common goal of good best practices, and having this good, I want to say the word assurances about the quality of different projects. And yeah, a lot of very very talented people, doing their best and to build really good communities as well. You talk about the kind of social engineering that happened for that XE utils vulnerability. One of the nice things about CNCF is an awful lot of people who know each other, and you're going to make it harder for people to compromise code if you have relationships, in-person relationships and on Zoom relationships, as well as not just GitHub. And yes, there's a lot about the community that's really, really valuable.
It's really interesting and dynamic, and I think what was achieved so far by CNCF and its governance is super impressive. Uh, Before we're finishing today's episode, for those who want to learn more about Cilium, about Isovalent, let's first mention explicitly that Isovalent was recently acquired by a small company named Cisco. Is that right?
That is true. Yes, yeah, we literally just closed that deal a few days ago. So as we're recording, so yeah, haven't been through my Cisco onboarding yet, but I'm very excited about it.
That's awesome. And I think, it's important to mention that Cisco, at least from my point of view, is becoming more aware of modern technologies and cloud native, and thinking how to transition to the modern data center or cloud management when it comes to, first of all, security. So Isovalent acquisition, I think, is very interesting to see coming from Cisco. And important to mention, I think, the Splunk acquisition a few months ago, dramatic acquisition by Cisco. So those who want to learn more now should see the Isovalent product or a platform within Cisco wider ecosystem. And obviously, Cilium was and will remain a CNCF project.
Absolutely. I mean, the fact that it is in the CNCF, should give people a lot of confidence, because, Cisco are really bought into supporting our open source mission, and I firmly believe that. But I can't guarantee that in 5 years' time Cisco's objectives might have changed. I don't think they will, but they might have done. But it doesn't matter from the perspective of the project, because the project is owned by the foundation. So that gives
Mhm.
this kind of longevity. We can't change the license, for example. There's no uh,
Rug pulls.
we don't own it anymore. We can contribute to
Yeah,
it,
yeah,
we can guide it, we can
yep,
steer it as a collective of committers. But yeah, it's no longer our own as
yep,
a company. It's no longer our intellectual property. But I think that's a
exactly.
good thing. You know.
I fully agree. And we see vendors every now and then uh, decide all of a sudden to change the license or the community involvement or both within open source project. We've just seen recently Redis doing something like that. I'm very familiar with the HashiCorp license change that happened 8 months ago. But as you mentioned, if something is within the Linux Foundation and within the CNCF, this IP doesn't belong to a vendor. The IP, the copyright, everything, the trademarks, everything involved around that belong to a nonprofit foundation, and therefore nobody can change the license. Nobody can change the involvement of the community, being impartial of such important and strategic project to so many customers and production environments. So good luck with your next journey in Cisco, and thank you for making Cilium such an amazing project, all the way to graduated CNCF and affecting everybody's life with, especially when it comes to networking and security of cloud native environments. And thank you, Liz Rice, for joining our episode today. I really enjoyed listening to your observations and your thoughts. Thank you so much.
Thank you for having me.